we're going to start talking about, we get to learn how to start naming alkanes, which we already kind of be able to figure it out. Hopefully you're keeping up with doing your reading and stuff online. Do not put this one off. It's going to get much more difficult if you procrastinate later on, because with each chapter it should become more and more difficult. All right, but we're going to start to learn how to name these. And these are the simplest alkanes. This first one, we're talking about the butanes, and they're going to go into pentanes and so on and so forth. It's very simple. This one example is to show you that it does matter, because if you compare butane to what you're going to figure out, well, they call it isobutane is a common name. That's not the IUPAC name. I almost always use IUPAC names, because if you have to try to memorize all of the common names, it makes it much more difficult. If you just learn the rationale behind IUPAC naming, it makes it so easier. The IUPAC name for that one, by the way, for isobutane, is 2-methylpropane. And that'll make more sense in a, hopefully either later today or if not on Wednesday. Okay? But if you notice, the physical properties for these are considerably different. All right. So methane, ethane, propane, they have no isomers. You know, they're as simple as it can get. There's no way. I've had some people forget, and they drop propane, and what they do is they move that one carbon off, they stick on the other carbon, it's just pointing down, and they think that they've drawn, a methyl ethane. I'm like, well, it can't be. Just count. There's still 3 there. But it's one of those are the kind of answers where people are in a hurry. However, butane has 2 isomers. You can have it where it's a straight chain, and it's called butane because it's an alkane. It's got 4, meth, eth, prop, but. So butane, okay? And then you can have 2-methylpropane. Everything is sp3 hybridized. So, how did I get the name 2-methylpropane? I'm just going to work out the example here. The PowerPoints in your book goes into greater details and makes it kind of wordy, but it's just really simple. So this is what it looks like. I mean, you could write it out with all the C's and the H's if you want to, but it's really simple to name this. What you do is you look at the longest continual chain, because right now we're not even talking about functional groups hanging off. So the longest chain, how many carbons are in the longest chain here? 3. And it doesn't matter if we go 1, 2, 3, or if you go 1, 2, 3 straight down. Okay? Since it's an alkane, that means the ending has to be ane. Ane. 3, the prefix for 3 is prop. Meth, eth, prop. Meth, eth, prop your butt. So that's propane, but now we have to do what's called a substituent. So this carbon group right here is hanging off. Okay, it's called a substituent. So how many carbons are in that chain that's hanging off of that? 1, and so the prefix for 1 is meth, but we wouldn't call this meth propane. That sounds really weird. Instead, they put an ending of YL. This YL right here, all that means is that signifies that it's a functional group hanging off. So when we say an alkyl group, this means it's a group of carbons hanging off. Methyl group means it's 1 carbon. Ethyl means it's 2. Propyl 3. Butyl 4. So on and so forth. Okay? You're going to find out now, you don't do the same thing with halogens. So don't think that as a fluorine, you don't call it fluorenyl, because then they end in O. Fluoro, bromo, chloro, iodo. But that's what that means. So this is methylpropane. Technically, you don't have to give the locant. The locant is the number that they sometimes stick in front of you. Probably if you look at the back of like your shampoo bottle, sometimes maybe it says like 1, 1, blah, 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 or whatever. Actually, it wouldn't be 1 necessarily, but that's beside the point. It gives all those numbers. Those numbers are called locants. This one, you don't have to, because there's only one way to draw methylpropane. If you move that methyl group to carbon 1 or carbon 3, it's no longer methylpropane, it's butane. However, It's also not wrong if you call it 2-methylpropane because it's hanging off of carbon number 2. This is carbon 1, that's carbon 2. So I wouldn't count off if you call it 2-methylpropane, but this is one time when you don't have to do the number. So what are times when you do have to do the number? So let's look at another example. That's just a single bond. It just didn't come out very well. I'll give you a chance to draw it. So we're going to start to look like we're drawing hieroglyphs. So on this one, the longest carbon-containing chain, how many carbons are in it? Okay, so, and first of all, are there any double bonds or triple bonds or anything like that in there? No, so what's the ending going to be? The ending, ane, for alkane. And it's 7, so what's the prefix for it? Hept, so this is heptane. But now we have a locant. Oh, not locant, a substituent. That substituent right there. And how many carbons are in that substituent? 1, and so it would be methyl. And now we do have to give the number because we actually have multiple places where that methyl could be hanging off. You know, 2-methyl versus 3-methyl versus 4-methyl versus whatever could be very different with their physical properties. So what carbon number is that one hanging off of? Oh, here 3, 4, 5. Thank God no one said 1 or 7 because then it wouldn't be that. So I deliberately picked this one for a couple of reasons. There are 2 ways to number it. We could number it in this color 1, 2, 3, 4. That's supposed to be 4, 5, 6, and 7. Or in the lighter color, we could number it 1, 2, 3, 4, 5, 6, and 7. One of those is correct. Is it going to be the darker color or the lighter color? The lighter color 3 because it's a lower number. Okay, so whenever you have the opportunity, you go with lower numbers, especially when there's one substituent hanging off. We're going to find out as we get to more and more complex organic compounds that, unlike people, not all substituents are created equal. Okay, and so, for example, alcohols get priority over alkyl groups, like methyl groups and ethyl groups. You'll find out later on, carboxylic acids get priority over alcohols. Okay, so let's do another example. Give you a moment to draw that and embrace it in its glory and beauty. I wanted to do ones where there are lots of possible ways of numbering and so on and so forth. And actually what we'll do, see that I kind of have that little knobby thing sticking out. I'm going to go ahead and make it another carbon. Because I forgot, there's something else I'm wanting to teach you guys, and I can't do it with what I had on before. Okay, on this one, first of all, are there any double bonds or single bonds? No. So the ending would be ane. What's the longest continuous carbon chain? How many? There are 8. Okay. And so now we've got a couple of different ways to number it. We can number it 1, 2, 3, 4, 5, 6, 7, 8. Or we can number it 1, 2, that's supposed to be 3. It really has problems with 4s. 5, 6, 7, and 8. We'll get back to the locants, because now we need to name the functional groups hanging off. We have this functional group here. We have this functional group, and we have this functional group. Okay. So, if we look only at, I'll start with the top, with that left-hand side. What kind of functional group is that one? That's a methyl group. Okay, let me change my colors back. So that one's a methyl group. The one right below it would be methyl. So, those are both methyl groups. What about the other one? That's ethyl, because there are 2 carbons in it. 1, 2 carbons, that's F, and you add the YL. So that's ethyl. So now, it doesn't matter which order that you put these in the name. Because I'm really bad at judging, you put them in alphabetical order, okay? I'm really, really bad at judging space. So the root to this, the root word for the naming is, it was ane, but how many was it? What if it was 8? What would the name be? Octane. I forgot to put that down there. So it's octane. All right. I'm really bad at engaging space. So I always go in reverse alphabetical order. So which comes last? Or further in the alphabet, methyl or ethyl? Methyl, which comes last in the alphabet, would be methyl. A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, so on and so forth. A, B, C, H, A, D, E, F, A, for those who, never mind. All right, but no, it's still the M. So it's going to be closest to the root word. Like I said, you could do it the other way, where you name it in alphabetical order first, but I don't ever, even just doing it this way, I have problems. I'm going to leave a space. Well, I'm going to leave a space just in general. Okay? And then, so ethyl. Now we have to give locants. Notice that those are dashes. So I'm going to do the ethyl first. What number should it get? It's going to be either a 4 or a 5. So, but that's the quandary that we're in. It will either be a 4 ethyl and a 5,5 for the methyls, or it's going to be a 5 ethyl and a 4,4 for the methyls. All of these are equal in their priority because they are all alkyl groups. It's not like we have an alcohol or carboxylic acid or something like that hanging off. So that means that they're all on equal standing. So we have to think lowest numbers. You have to go with whatever gives the lowest number. And lowest number would be the 4 for the methyls, because we have 2 of them, and the 5 for the ethyl. Now, that being said, if the ethyl group was hanging off of the carbon that says 7 and 2, then we would go with the lowest number would be 2. Okay, because that's the first difference. It's called the lowest first difference, I think, or something. But that's why you have to go with the lowest numbering, assuming that everything else is of the same priority in the hierarchy. Anything with an oxygen trumps things that only have carbons in general. All right, so that being said, the ethyl got a 5. And now we have methyls. But how many methyls do we have total? 2. So we can't just say methyl octane, because that implies that there's just 1. So we have to give another prefix, and that's di. Okay? Just like if there were 3, it'd be tri. 4 would be tetra. 5 would be penta, and then hexa. You don't really see much beyond penta and hexa, really, because by that time, it would be really complicated. So di and tri are by far the ones that you see the most. But you can have tetras. By the way, if there are substituents of substituents, you can also have tetrakis and pentakis and all this kind of stuff. But all right, so this is di. Di. And we have to give the locants. And so what numbers would it be? 4 and 4. And you've got to give both of them. And the reason why is you could have 3 and 4. You could have 2 and 4. You cannot have 1 and 4, because otherwise it wouldn't be octane, it would be nonane. So this is 5-ethyl 4,4-dimethyloctane. Plus, you can also go backwards. So now, this next time, I'm going to give you the name and give you guys a moment to draw it. So 3-ethyl 4,4,6-trimethyl decane. So yeah, this one's a little trickier. First of all, are there any double bonds or triple bonds? No. And what's the longest carbon-containing chain? Like how many are in the longest one? There's 8. And so that would be, the root word for it would be octane. Now, if we start numbering, both of the functional groups on this one's hang off the same carbon. Are we going to start numbering from the right or the left? Which one's going to produce the lowest number? The lower number, I should say. Coming from the right, okay? And so the locant number for that would be 4. We'll just keep that in mind. Okay, let's look at this one first. How many carbons are in that one? 3. So what will it be called? Propyl. And so I'm just going to write it out here in a different color. We got to figure out if it comes first or last in alphabetical order. Now we have this one. Okay, well, this one's got a common name of isopropyl, but it has an IUPAC name, too. So what you do here is you treat it as a substituent of a substituent. It's a lot like math. There's math in this sense that you do everything in the parentheses first. That kind of idea. That's sort of like this. So you can treat, and it doesn't matter which one of these carbon groups it is. I'm about to give it away. You can treat this one as being a substituent of this, or vice versa. So if that was by its, how many carbons are in that longest chain that's directly attached to the parent chain? 2. And so it would be called, that would be an ethyl group. Oops, that's supposed to be ethyl. It just leaves this carbon right here. And how many carbons are in it? 1. So it's called a methyl group. Oh, it's supposed to be an H, but it's not wouldn't come out. That's one thing I'm really bad with trying to judge space. This is supposed to say methyl ethyl. However, we still have to give it a locant. And so a lot of times they call it, sometimes they'll, when you guys get used to it, a methyl ethyl is the only one way, but sometimes you'll see it as a 1-methyl ethyl because it's hanging off of the first carbon of that ethyl group. So that's why I'm going to do it this way. In reality, for isopropyl groups, you can only do it one way. But it's perfectly fine to say that's a 1-methyl ethyl group. That methyl group is hanging off of the first carbon of the ethyl. Okay? Now, that one starts with an M, and propyl starts with a P. So which one comes last in alphabetical order? The propyl. So that means it's going to go next to octane when we write it out. It's supposed to be a Y. And we have to give its locant, which was a 4, which is what we already said. Then, and I just wanted to get you to get used to seeing parentheses. Like I say, methyl ethyl, there's only one way to draw a methyl ethyl group. But you could have a methyl propyl group hanging off, not in this instance, but you could have methyl propyl groups or methyl butyl or something like that. And then you have to give the locant for it. So that's why I just wanted you to see what it looks like when you see things in parentheses. This is supposed to be methyl ethyl, but I don't know that I left enough space. Oh, not too shabby. And then we give its locant. And so if you were drawing this, so it's 4, 1-methyl ethyl, 4 propyloctane. Or this is one of the few times where you could leave that 1 off and be 4. But in the parentheses, I'd put the parentheses just to be on the safe side. So that way you can tell, like it's not methyl ethyl and 4-propyl octane. But many times you do see the 1-methyl ethyl just because people like to always show that. The common name for it, once again, is called isopropyl, because it's in the middle carbon of a 3-containing group. But I just want you to be able to see that and be able to go drawing it backwards too. So if I had given you 4, 1-methyl ethyl, 4-propyl octane, you know the root is all single bonds. It has 8 carbons. Hanging off of carbon number 4, something's got 3. Hanging off of carbon number 4 is something's got 2 carbons, and off that first carbon off of it's another carbon. Kind of looks like the little V, which you'll find out it's important in biochemistry for those who take biochemistry. Okay, how are we doing on time? Good. So essentially that's what this is, like I said, this goes through and talks about all of this. They tell you the common names like isopentane and neopentane. Other than since I can't choose all the questions on the quizzes, I want you to know some of them we do use, like T-butyl, a T-butyl group, and isopropyl alcohol, for example, they enter in your common vernacular. But like, I would never ask you on a quiz or an exam in class to draw a neopentane because it becomes a little bit more complex, and there's just too many common names to have to remember. So this is what they're talking here is the whole IUPAC. It tells you we've already memorized meth through DEC. Okay? And then it talks about how to apply these rules and to do it systematically. Right? And so on your own, I'll try to have this PowerPoint up either later today or tomorrow, but it just goes through the exact same thing that we did by hand. And I'll go ahead now in class.